There are three types of properties for dental materials. First is the physical properties, mechanical properties, and the electrical properties. Physical properties are based on the laws of physics that describe mass, energy, force, light, and other physical phenomena. There are many examples for physical properties, but I will only give three examples. First is the thermal conductivity. Thermal conductivity is the rate of heat flow to a material. Here is an example of thermal conductivity. Here is a pot and a gasoline. After many minutes of waiting, we can observe that the pot will slowly get hot. First at the bottom of it because it is near the fire. This is how a thermal conductivity works when there is a transfer of heat through a material. First, we assume that the pot is not hot, right? And then after we put a fire on it, slowly it will become hot. So thermal conductivity only works when there is hot or the transfer of heat. The next example of physical properties is the solubility. Solubility is the property of a solid capable of being dissolved. In testing solubility, I will be using three samples: sugar, powdered juice, and powdered milk. And now these are the three samples. As you can observe, the sugar and the powdered juice are well dissolved in water because as you can observe on the upper portion of it, they are so clear. While compared to the powdered milk, as you can observe, there are some particles floating above it. So it is only partially dissolved. So this is how a solubility works, where a property of a solid capable of being dissolved. The third example of physical property is the viscosity. Viscosity is the resistance to flow or motion. In testing the viscosity, I will be using the liquid soap as the substitute of honey and water. I will pour them together into the plastic container to see which is more viscous, if it's the liquid soap or the water. As you can see, the liquid soap is more viscous compared to water because it flows slowly, while the water has a low viscosity because it flows readily, like this.
Hey there! So I'm going to give you some examples about mechanical properties. Now, mechanical properties, these are properties by which a material exhibit upon application of force. Now, it is also defined by the laws of mechanics. Now, what we have here first is a rubber band, and what I am doing to the rubber band is I am stretching it. More specifically, I am applying tensile force that causes tensile stress to the material. Now, tensile stress is a type of stress subjected to a material when it is pulled apart like this. Now, when I try to relieve it from stress by letting it goes back to its original shape. Now, it is called elastic strain. Strain here is a deformation of a material when force is applied. Elastic strain, on the other hand, is a temporary or reversible type of deformation that when stress applied is removed, it goes back to its original shape, like this. Like this. Now, when I try to apply more force and more tensile stress to the material, to the point that it will break like this, the stress applied before it broke is what we call ultimate strength, or more specifically, tensile strength. Now, tensile strength is the maximum conventional stress that this object can sustain, where like somehow it is the level of stress required for this material to break. Second, what I have here is a stapler. Now, what causes a stapler to go up when we try to push it down is the spring located at the back. Now, I have a smaller version here which I got from a ball pen. Now, when I try to compress it or squeeze it, we are applying compressive force that causes compressive stress. And when we try to pull it apart like this, we are applying tensile force that causes tensile stress. Now, both forces and stress, when removed, the spring goes back to its original shape, like this. Now, when we try to apply more tensile stress and tensile force, like this, it results to this kind of deformation. Now, this kind of deformation is what we call plastic strain. Plastic strain is a irreversible and permanent type of deformation. It is when a material is stressed beyond proportional limit. Lastly, what we have here is a paper and a scissor. Now, when we try to cut this paper, we are applying shear forces parallel to the cross-section, creating shear stress. Now, shear stress acts parallel to a surface, which causes one object to slide over another. Now, let's hear more examples about electrical properties.
The third is the electrical properties. Electrical properties refers to how a material will respond to the application of an electric field. The first electrical properties is the conductor. Conductor is a material that allows the flow of electric current in one or more directions. One example of conductor is the metal. Metal such as spoon, fork, and pots. Most metals are good electrical conductors because they allow the transmission of heat or light from one source to another. The second electrical properties is the insulator. Insulators are materials that offer high resistance to the flow of electric current. Examples of insulators are the plastic, glass, and electrical wire. Glass provides high resistance to the flow of electric current. Electrical wires are insulated with plastic cover because plastic are good electrical insulator. It does not conduct electricity at all, so we can touch the electrical wire without getting a shock because of the plastic cover.
Another example is this charger wire. Inside this charger wire are bundles of copper, which are metals and is a good electrical conductor that allows the flow of electrical current from one or more direction. Surrounding these copper wires is this orange rubber, which serves as an insulator that does not allow any flow of electrical current or charges. Same with your plastic, glass, and wood. Now, same with your dental materials. When dealing with different metals placed near each other on our tooth can generate electrical current, which can cause pain and discomfort. Now, with your temporary polymer crowns made with acrylic resins, for example, can be used to prevent this kind of problem, for they are poor electrical conductors, just like insulators.
That's the end of our report. Thank you and God bless. Happy New Year!